All right, this lesson is in chapter 4. It's on factoring and using factoring to solve quadratics. So this is a whole nother section on how to solve quadratics. Basically, we're going to look at trinomials and binomials and breaking them down to factored form and solving. Okay, so the first thing we want to recall from the 4, a lot of times we saw this word FOIL. We want to make sure we know what that means. A lot of times I refer to it as double distribution. Basically, it's like this. You take the first term and you multiply it by the first term, you get x squared. By the second term, you get 7x. Then you do the exact same thing for the second term. So I'm going to distribute the 4 now times 4x, and then 4 times 7 is 28. Now you look at everything here and say, okay, what can we combine? Our middle terms. We're basically going to add them together, and we have x squared plus 11x plus 28. And again, we're in our ax squared form. Plus bx plus c. So that's the form we want to get into, and this would be all distributed out. Okay. So now let's look over here. What does reverse FOILing do for us? Well, we're going to be given problems like x squared plus 11x plus 28, and we want to go backwards. So a very simple example here is x squared plus 5x plus 6, and we want to put it into a factored form. Something that looks like that. So we have to look. All right. What's our middle term? The middle term is the two numbers added together. And then the last term is the two numbers multiplied together. So we have to think, what are two numbers that multiply to 6 that add together to 5? Well, that's going to be 2 and 3. And we want to follow suit with that. So again, this going backwards of the distribution process is that's what happens. The middle term is the added term. The last term is the multiplied term. So again, this should be refreshing some memories from first year algebra as well. All right, so let's take a look here. How do we factor these two things? So again, I'm going to think of two numbers that add up to -9 that again multiply to 20. Now again, if you get stuck on what numbers multiply to 20, a lot of you think, oh, I can do those in my head. Well, if you get stuck and the numbers are bigger, write them out. I always like to start with 1 and 20, okay? The number itself and 1, and work backwards. Does 2 go into 20? Sure it does, 10 times. Does 3? No. 4 does 5 times. And notice once you get to 4, it goes back to 5, and you go back up the chain again. So those are all the combinations that multiply to 20. Which ones add up to 9? Right there. Okay, so those are the two numbers we're going to need. Now notice it's a -9, so I'm going to have x minus 4 and x minus 5. So this is the factored form of x squared minus 9x plus 20. Okay. So again, we want to be able to get really good at this because we're going to use this then to solve. Look at this example over here. Again, I'm going to look at 12. Again, I'll just write them out real quick. 2 and 6, 3 and 4, and that's about all we're going to get. So which ones are now, look at -12, so which ones are 3 apart? So we're going to take a look here, and we really don't have any one that are 3 apart. Okay. So this one looks like we can't factor at all because notice there's no combinations that come to 12 that are 3 apart. So we would call this one simply this prime. It cannot be factored. Okay. And that's fine. You're going to come across problems like this that you can't do factoring wise. So then what do? You complete the square, force it to a thing that can be solved, and so forth. Okay. So again, factoring works for a lot of problems, but not everything. Not everything can be factored nice and cleanly. So this one here, we can't do. So we just call it prime, can't be factored, can't be broken down. So we're just going to leave it just like that. Okay, now look at this. Solve by factoring. So we have to know what is the difference between solving and factoring. Well, notice here, I'm going to scroll back to the last page. These are expressions. They do not have equal signs anywhere in here. Whereas these do have equal signs, so we can solve them. You cannot solve unless it has the equal sign. You can only solve equations. So that's the difference between solving and factoring. Solving goes with equations which have equal signs. Factoring goes with expressions which don't have equal signs. All right, so let's first factor these elements. So I'm going to look at this, break it down. So, okay, give me two numbers that add up to 20 that get to -9. So I'm going to be x minus 4 and x minus 5. And again, equals 0. Don't forget that now. Okay. And again, I'm going to factor the bottom one down here as well. So we have x squared plus 3x minus 12 equals 0. And then here again, we can't do that one. as far as factoring. So we would just do this one a different method by completing a square. And we'll show that later. Okay. But now let's look at the top one. How do we go ahead and use zero product law? Well, zero product law says any number times a number, if that equals 0, the only way that happens is if either A or B independently equals 0. So let's say A was 0. Well, 0 times B is equal to 0. Well, that makes sense. So let's put lines in there so we can see it. Or let's say B was 0. A could be whatever it is. Any number times 0, then it's going to equal 0. So in order for the product to be 0, either A has to be 0 or B. So therefore, over here, if the product is equal to 0, then either the first part has to equal 0 or the second part. And either one would work. So now we just go ahead and separate the equation. And we have x minus 4 is equal to 0. And then x minus 5 is equal to 0. And here's our two possible solutions from the quadratic. And again, we have x equals 4, move the number over, and x equals 5. So again, those are the two possible solutions for this quadratic. Okay. And again, we're going to look at, the next problem here. We can't factor it, so we're going to look a little later. I'm going to give you a different example of how can we do that one. So we'll probably do that one in class. Okay, talk about, completing the square and how the difference between the two is. All right, here's special cases. Okay, this is called difference of perfect squares, and then perfect square trinomials. This is what we worked on in completing the square, so that's pretty much the same thing. The difference of two squares is this. If there's no middle term, x squared minus 9, that's really the same thing as x squared plus 0x minus 9. Well, give me two numbers that multiply to 9 that add together to get 0. Well, that'd be positive 3 and negative 3. So you're going to show it that way. It is the exact same thing, but one's positive, one's negative. So we're going to show it that way, almost kind of like conjugates, where that middle term drops out. The same principle applies here. So let's look at q squared minus 10. If I can take the perfect square of both the first and second term, I'm going to do that. What's the square root of q squared? Well, that's going to be q and q. Square root of 100 is 10 and 10. And again, difference, because one's negative, one's positive. If you put those together, they'll always equal a negative. So that is the factored form. And again, set them equal to 0, set them equal to 0. So this first one is going to be x is going to equal either positive or negative 3. If I set each part equal to 0. And this one over here is going to be q is equal to positive or negative 10. Okay. Nice and simple. Looking at the two down here, these are perfect square trinomials. So this is almost like completing the square, looking for that pattern. I see the middle term's doubled, the last term is squared. So this is simply y plus 8 quantity squared. I can write it like that. Over here again, w minus 9 quantity squared. So again, I'm looking. 9 doubled is 18. 9 squared is 81. Checks out. So those are the two things we're looking for. So again, those are the special cases that we come about in the factoring form as well. Okay, now we're going to talk about what happens when a does not equal 1. We have a number in front of x squared, both here and here. What do we do with that? Okay, well, a lot of times, I'm not sure how you learn and stuff. Sometimes we just go do almost like a guess and check method. So I'm going to start with two parentheses. Set them equal to 0. So, okay, how do I break up 5? Well, that can be broken up as 5x and x. And how do I break up 6? Well, there's a lot of different ways you can do it. We could do 1 and 6 or 2 or 3. I'm going to just go do 2 and 3. Now, notice I'm just going to fill in 2 and 3 randomly and say, okay, we want to get a combination of 17. So we're going to look and say, okay, let's make this one negative and this one negative because they both have to equal a positive 6. And here we have negative 2x. And here we have negative 17x, and what we have here, not 17, how about 15x? If we add them together, we get negative 17x, and that's exactly what we want. So if we distributed out this pair of parentheses, we would get the middle term we wanted. So that is how we want to go through that. Now again, it's a lot of guess and check. If you didn't have the 2 and the 3 in the right spot, you may have to switch them. If you didn't have the right signs, you might have to switch them. But it's almost kind of like a guess and check method, where you factor out the A factor, factor out the C factor, and you play with the position and figure out what works. Okay. Now notice in the second one, the special case over here, notice we only have two terms separated by a minus sign. So that's the difference of perfect squares. So when we recognize this, I'm going to go ahead and set up my equation. And then I'm going to say, all right, let's just take the square root of the front, take the square root of the back, and the square root of 9x squared is 3x here and 3x there. The square root of the back is simply 5 and 5. Since it's the difference of perfect squares, one has to be negative, one has to be positive. Okay? Now, all we've done right now is factored. We still have to go through and solve. So what I have to do is set each part equal to 0. So we're going to have over here 5x minus 2 is equal to 0, and x minus 3 is equal to 0. Notice here we're going to have 5x is equal to positive 2, divided by 5, and we have 2/5 as one answer. And simply here we have x is equal to 3. So my two answers to that problem are 2/5 and 3. Over here, we're going to have 3x minus 5 is equal to 0, and 3x plus 5 is equal to 0. Now notice, going through the same operations, we have 3x is equal to 5, x is equal to 5/3. And over here, we're going to have this pretty much the same thing, but only the negative case. So we're going to have x is going to equal to negative 5/3. And again, we have our two answers there. Some people say, hey, can we just go ahead and write it like this? X is equal to plus or minus 5/3, and that is totally acceptable as well. Okay, and again, well, you could just go ahead and take the square root here. But again, the purpose of this chapter is knowing how to do quadratics several different ways. So this way, you could either take the square root or you could factor it. Both are going to yield the same answer. All right, now, what I'm going to introduce here is a system called split middle term. Now, this is an optional method. So a lot of people looking at this last slide here, you know, almost do like this guess and check method where you put the things in positions and make sure it works out. Well, we could do the same problem, but use a different method. So this is called split middle terms. I want to introduce you because sometimes students like it. It's a little bit more systematic, which I like. It has a little bit element of guess in it, but it's right in the beginning. And once you get that figured out, the rest falls in place. So what we want to do is, this works especially well when you have an a factor, not 1. So I'm going to take the a and the c and multiply them together. And the a times c is simply negative 24. And we have to think, what numbers come up to be negative 24? Well, we have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And we have to think, okay, which ones, since it's negative, are 5 apart? And we're looking now at the middle term. Well, that's going to be 3 and 8. So can we take 3 and 8 and make 5? Sure we can. So I'm going to rewrite the original equation now by splitting the middle term. So watch what happens here. I'm going to take the 6x squared, write it down, put the negative 4, write it down. And instead of writing 5x, I'm going to write positive 8x minus 3x. And I think we could all agree, if I take 8 minus 3, I still get 5x. So I haven't really changed it. All I did was split it up. Now by splitting the middle term, I can look at this as two different pieces. I'm going to look at the front and say, what's the GCF, the greatest common factor of the front? Well, I can take a 2 out and an x out, and I'm left with 3x plus 4. If I do the same thing in the back, I'm going to say, okay, what can I take out? Well, I see this negative here. I don't like to have negatives in my final parentheses, so I'm going to go ahead and factor out a negative. So I'm going to take out a negative 1 and be left with 3x plus 4. Now, all I did was take the GCF out of the front half, which is the left, and the back half, which is the right here on the sides of the squiggle. Notice that these two elements are identical. When that happens, that's evidence that this thing is factorable. So we say, okay, what can I take out of both the first term, which is this, and the second term? Let's put it equals 0 here. They both have a common element in them. So I can factor that out. So out there, I'm going to take out 3x plus 4. And I say, okay, if I factor that out, what's left? Well, I have a 2x minus 1. And I'm going to write that as my other set of parentheses, 2x minus 1. And all I'm doing is factoring out the parentheses. I've separated it and taken out what is common, and the green shows what's left. And we now have set up zero product law. So equals 0. So now we can say, all right, 3x plus 4 is equal to 0, and then 2x minus 1 is equal to 0. And our final answer is going to be negative 4/3. And then over here, positive 1/2. So again, this is a nice way because it follows a pattern, systematic. So for those that like that richness of algebra, this is a good way to do factoring with that. Okay. because it follows the same rules of algebra. Okay, so that's how we do it. Now again, if I did the guess and check method, okay, actually, this should actually be over here, and then vice versa. I kind of did these backwards. So what I actually did was split middle term. Over here, I'm going to do the guess and check. So what I would have to do is set up my parentheses and say, okay, what can we do here? Now again, if I didn't know what it was, I might have started with 6x and x, and I might have started with 4 and 1, and 1 negative and positive, and realize, well, that's 1x, and this is negative 24, and so forth, and realize, well, that doesn't work, so what do you have to do? You have to go ahead and erase, start over a little bit, and maybe come up with a new combination. Try 4 over here, and then 1 over here. Realize it doesn't work again. And you may do this several times before you get the product that you want. Okay, and in our case, we wanted the product 3x plus 4, and then 2x minus 1. Okay. So again, you can guess and check and go through until you get something you like and realize, oh, that's 8x, and this is negative 3x for a total of positive 5x, which works. So either method works. Okay. I just want to introduce split middle term so you can kind of see the difference. Okay. That's really it for right now. I want you to try these 6 problems over the weekend. Okay, and again, a lot of these should just be somewhat review from algebra, this factoring. But again, we're going to take this, to the next level, and it's going to get a little more dense. So, review the lesson and try these problems.